This is a tutorial video to show you how you can build customer churn prediction model, deploy an API, and build application on top of it using SnapLogic. So if you go to SnapLogic Machine Learning Showcase and click Try Demo, go to the customer churn prediction one. You can see here there will be a chart on the right and some description on the left. So in this case, we separate the customer into two groups. The one who already left our service, we call it a churn equals to yes, and the one who are still using our services as a no on the left. The churn on the right and not churn yet on the left. So as you can see here, the one who use fiber optic as their internet services are likely to churn because as you can see, there's a big segment, the big ratio of fiber optics on the churn side. You can change to see different columns. So this graph is plotted using a SnapLogic pipeline with a Bokeh library in Python and then deployed as an API so the UI can send a request and get back the visualization. So if you scroll down a little bit, you see a kind of spreadsheet that contains the customer information and the services that they are subscribing. So on the rightmost columns, you see the prediction from our machine learning model. So in this case, the first customer are likely to stay with us with the confidence level of 94%. The second customers are likely to churn with a confidence level of 68%. So we see from the visualization that the fiber optic may be the cause of churning. Why don't we try and change it? So when it changed from DSL to fiber optics, as you can see here, the prediction changed from 68 to 93%. If I do the same thing, you can see here, no drop, yes increase, no drop, yes increase. So that means the fiber optic could be a significant factor, and we should resolve the issue right away before losing more customers who are using the fiber optics. So this spreadsheet or this application will help customer services to identify the customer who are not happy with our service and are likely to churn. Then we can come back with the promotion or ask for their feedback and how can we do better in order to keep them as customers. So how we build this model? So go to a SnapLogic designer and import the pipeline. You'll be able to get this pipeline, and then let me validate the pipeline. So the first one is the file reader that reads the dataset from GitHub. Then we use the CSV parser to parse the dataset, and here's what the dataset looks like. So it contains a customer ID, other subscription services that they are using, monthly chart, total chart, and churn. So there's some missing total chart which we will handle next. So the first one is the type converter. So everything in CSV will be parsed as string. So we use an automatic type converter, including specify that the senior citizen columns, which you can see here is 0 and 1, but it actually should be a string, not a number, because it's a categorical feature. Then we remove the customer ID because the identifier doesn't help in building a machine learning model. Then we split the data into two flows, do some profiling, and as you can see here, this is the profile of this data set. You can click New tab to see the profile. We can see that there's about 5,000 customers who are still using our services, and there's almost 2,000 customers who already left our service. You can see others like monthly chart. Most of the customers pay less than $30, and then there's a few customers who pay quite significant amount monthly. So let's go back and do some clean missing value. So as we see here, there are missing value in the total chart. So we use the clean missing value snap to handle it. Say this total chart, and we're going to impute it with the average. So the custom value type, and so on. So now we use the AutoML snaps. So in this snap, you specify the columns that you want to predict. then set the time limit and the number of model. You can select between H2O engine and Vega engine, and you can also select the algorithm groups that you want. In this case, I want to try all of them. I want to build 10 model, and I set the time limit to be 1 hour or 3600 seconds. So we then let's try it out. So I have already run the pipeline, and then I'll get the model. So the model will be serialized, and you can see it that there are summaries, there are metadata, and there are model. We will use this model to deploy it as an API later on in the next pipeline. Second, we get the leaderboard. The leaderboard tells you the models that built and also the statistic. We also provide the report in a visual format, which you can see here when you write it out as HTML file. So click New tab to see it in a full preview, and as you can see here, when we full run it, when we execute the pipeline, we build 10 models, and the best accuracy we get is around 77.4%. You can see that we have quite a amount of customers who are not churning, and we have about 20% of customers who are churning. We get a confusion metric here, and we get others information here like precision, recall, and F1. So as you can see here, we're gonna use the XGBoost. So the next time you run, because you're gonna get more and more data, so the next time you run, you can get the second input of the AutoML snaps, and then you can fit it with the best so far model. So this is something similar to like checkpointing, where you can start training based on the best so far model. So the concept of AutoML is that you want to train, you want to try as many as model as possible, then you select the best model with the metric that you define. In this case, the simplest one is the accuracy. So if I connect this, when I run it, it will build the best so far model on a new stream of data before trying a different set of model. So in this case, you keep running this pipeline, you get a better and a better and a better model. So this is the pipeline that you can deploy as an API so that you can connect to the web application. So the core component is the predictor snaps, which we supplied with the model that we built from the previous pipeline. So we have a mapper that extracts the parameters from the request. So the content is the request body. We have some filter just to check the token. You can use database select or other snap to do authentication of your choice. Then you can prepare the response, adding the header to support cross-origin resource sharing. So that's up to you. Then you can also deploy it as an Ultra. So the good thing about Ultra is that it has a very, very low latency. So you can select the Snaplex, you can change the name of it, and then you'll be able to set the bearer token here as well. We would recommend you to do authentication inside the pipeline using filter snap or using other kind of authentication method. So once you deploy it, you're gonna get an API which you can use to do this. So let me get the inspector on to show you what the API look like. If you go to the network tab, I change something, then you can see that the UI send a request to the outer task. If you click on that, you can see this is what the input look like. So it contains information about the customers, and the response is a prediction saying not churning with a confidence of 93%. So if you are interested more in doing the data science with SnapLogic, you can go and try out more of the demo. We have the loan repayment prediction, we have other cool stuff, and you can also test your API in the ML API tester, which we have some example, whether it's gonna be just a simple numeric data, whether it's gonna be images data, or whether it's gonna be the text data. So thanks for watching, and see you next time.